series and parallel circuits. By the end of this lesson, you should be able to identify series and parallel circuits, compare the current and potential difference of series circuits and parallel circuits. One of the bulbs is not working. Why do other bulbs still light up? Click on the switch. In the hairdryer, the fan and the heating element are arranged one after the other in a circuit. When both are in working condition, hot air is blown out of the hairdryer. What happens if either one of them is not working? When the circuit is complete, current will flow along the same path through both bulbs. This arrangement is known as a series circuit. What will happen if one of the bulbs is not working or burns out? As there is only one path for the current to flow, a spoiled bulb will break or open the circuit, thus no current will flow. This will cause the other bulb not to light up. What happens to the brightness of the bulbs in the series circuit when more bulbs are added to the circuit? The addition of more bulbs in the series circuit will result in a greater total resistance. This causes the current flowing through the bulbs to decrease, thus the bulbs become dimmer. When the circuit is complete, current will flow along different paths through each bulb. This arrangement is known as a parallel circuit. What will happen if one of the bulbs is not working or burns out? If one bulb is not working or burns out, other bulbs on the other paths will still light up. This is because current can still flow in other paths. What happens to the brightness of the bulbs in the circuit when more bulbs are added in parallel? As other bulbs are introduced in the circuit, the total resistance in the circuit will decrease. This results in an increase in total current flow. However, the current that passes through each bulb remains the same. Thus, the brightness of the bulbs is unchanged. Both bulbs have the same power rating. What can you say about the brightness of the bulbs? The bulbs have the same brightness. What can you say about the current that passes through the bulbs? Since there is only one path, the current that passes through each bulb is the same. What can you say about the brightness of the bulbs? The bulbs have different brightness. What can you say about the current that passes through the bulbs? Since there is only one path, the current that passes through each bulb is the same, but the bulbs have different brightness due to different power ratings. This is a circuit in an electric jug. The circuit consists of the power supply, the fuse, the heating element, and a switch. What type of circuit is shown? The circuit is a series circuit. What can you say about the amount of current passing through the heating element and the fuse? In the series circuit, the current passing through the heating element and the fuse is the same. If the current passing through the heater is 4.5 amperes, how much current is passing through the fuse? The fuse is in series with the heating element, therefore the current passing through the fuse is also 4.5 amperes. Why is it necessary for the fuse to be arranged in series in the circuit? The fuse is always arranged in series so that it can break the circuit should there be an overflow or leakage of current. A series circuit consisting of 3 bulbs of different resistances has been set up. Note the ammeter and voltmeter readings when the circuit is closed. Mouse over the meters to observe the readings. Click on the meters to record the readings. What can you say about the current passing through the series circuit? What can you say about the potential differences in the circuit? In a series circuit, the main current, I, is the same along its path. Thus, I equals I1 equals I2 equals I3. The potential difference of the battery is equal to the sum of the potential differences across the bulbs. V equals V1 plus V2 plus V3. Thus, in a series circuit, 1. The amount of current that flows is the same through all the electrical components in its path. 2. The sum of the potential differences across each electrical component is equal to the potential difference of the battery. A parallel circuit consisting of 2 bulbs of different resistances is set up. What are the readings of the ammeters when the circuit is closed? Mouse over the meters to observe the readings. Click on the meters to record the readings. What can you say about the current passing through the bulbs? In a parallel circuit, the current I is the sum of the current that passes through the bulbs. I equals I1 plus I2. A parallel circuit consisting of 2 bulbs of different resistances is set up. Note the ammeter and voltmeter readings when the circuit is closed. Mouse over the meters to observe the readings. Click on the meters to record the readings. What can you say about the current path of the parallel circuit? What can you say about the potential differences in the parallel circuit? In a parallel circuit, the main current I is divided into each path. Thus, I equals I1 plus I2. The potential differences across the bulbs are the same and equal to the potential difference of the battery. V equals V1 equals V2. Thus, in a parallel circuit, 1. The current divides itself between each path. The amount of current flowing in each path depends on the resistance of electrical component in its path. 2. Potential difference across each electrical component is the same and equal to the potential difference of the battery. This is a breadboard, or commonly known as a strip board. The breadboard consists of blocks of plastic with holes into which wires can be inserted. The holes are connected electrically, so that wires stuck in the connected holes are also connected electrically. The connected holes are arranged in rows. Electrical components can be quickly connected just by plugging their wires into connected holes on the breadboard. Rearrangement of the circuit is made easy by just pulling the wire or electrical components out of the hole and replaced by other components or moved to other spots. This is a portion of the breadboard. Form a series circuit on the breadboard using both bulbs and both batteries. You may rotate the bulbs and the batteries by clicking on the Rotate button. When you have completed, click on the Check button. Form a parallel circuit on the breadboard using both bulbs and both batteries. You may rotate the bulbs and the batteries by clicking on the Rotate button. When you are done, click on the Check button. drag and drop the bulbs into the boxes in the circuits, so that the two working bulbs will light up. Click on the switch to check your arrangement.